Okay, in this video we're going to look at kinetic particle theory, or it's more commonly known as particle theory in general. And the basis of it is that all matter is made up of particles which constantly move and interact. And basically kinetic particle theory is a theory which explains this phenomenon, and then we use that to explain different properties of substances. So why is a solid, why is a liquid, and why do they behave the way that they do. So to start this off, I thought we would revise some science from your junior years. So first we'll look at the three states of matter and the particle theory relating to that. And I'm going to explain the information in this table as we go through. So first we're going to look at solids here. So if you have a look, the particles are packed nice and tightly together. So they will vibrate slightly when in a solid, the particles, but they cannot move or slide past each other. So it's because of this and the way the particles are arranged that we have a definite shape for a solid. So it's why the table will hold its shape. A book you're reading will hold its shape because it is a solid, okay? It's not just going to fall apart and go flowing all over the floor. The same with its volume, it's going to be definite because these particles can't move. They're stuck in these positions, okay? The volume's not going to change of a solid. Compressibility, if you have a look and think about this, there is no real space between the particles, so we can't compress a solid. So I can jump up and down on a table as much as I want, and it's not going to be squished down and then bounce back. There's no room between these particles for a solid to be squished. Diffusion is the property of matter where basically, think of it with, say, if I spray a perfume in one corner of the room and then it will spread through the room. So diffusion is basically the property of particles spreading. So if we have a look again with the solid, these are packed tightly and stuck in place, so they can't diffuse or spread anywhere. Thermal expansion is basically when it's heated, there is a slight expansion here with the solid. They do expand slightly, but with continued heating, obviously they're going to change state and become a liquid, and we'll get into that later. So next we move on and look at liquids. The particles are arranged differently. They are close together when we compare between a gas and a liquid, but they have space to move around. So because this space is available, if we have a look at their properties, we can slightly compress them and they will diffuse slowly because they are able to move. They do slide past each other, so that's why we can pour a liquid. So you can pour yourself a glass of water, okay, or pour yourself a coffee. But the volume is definite because they still have an attraction between the particles, so they do hold a certain volume, so it's not changeable. But the bonds between the particles aren't strong enough for them to have a definite shape. So because of this, they're just going to take the shape of any container they're in. So for example, water on the floor just spreads out over the floor because there is no container holding it in place, whereas water in a cup will take the shape of the cup that it's in. It again expands to a higher degree when heated because there is more room for the particles to move faster, and hence the liquid will expand more. Then if we go and look at a gas, again the particles are further spread out. They have no real bonds between them, so they kind of just fly around everywhere. They again take the shape of the container they're in, and they're restricted by that shape, so the volume will vary because of the container it's in. So for example, in a classroom, the gas will take up the whole space of the classroom, but it's restricted by that. If it was let out the window, it can then has, a never-ending kind of space to occupy, so its volume would change. They're highly compressible, so there's lots of space between all of these orange particles, so we can squish them easily. If you clap your hands together, you're going to squish the air between your hands. That happens without very little effort at all. Diffusion is really fast, so as I said before with the perfume, if I spray it one corner of the room, you can smell it quite quickly in the other corner of the room, so the particles are moving at a high speed or rate. And this is also why there is a high thermal expansion with gases, because they're moving so fast, the more heat that's added, the more energy, they're going to move faster and faster. So now, speaking of that, we're going to look at how these particles change state. So basically all particles always have energy, so even the particles in a solid are vibrating. But as we heat them, we supply them with more energy, and the energy within the particles themselves increases, and then the properties of the substance will change, okay? So if we have a solid, so if we look down here at ice, so solid, think of like an ice cube on a hot day, even from the sun's light, it gets heat energy, and it causes these to vibrate faster and faster. Eventually they reach a certain temperature or speed or energy level where they're able to break their bonds and will end up melting to form a liquid. So then the particles are going to have the property of a liquid, and then if we add more and more heat energy, they're going to break the weak bonds that still exist between the particles, and the particles are able to move freely around, and then we get what's called a gas. So for different substances, there's different energy levels required for these changes to happen, and that's why things have different boiling points, different melting points. Okay, so looking over here, it's just important to know these key terms. So a solid changing to a liquid is melting, from a liquid to a gas is boiling, from a gas to a liquid is condensing, and so from a liquid to a solid is called freezing. So obviously if we're going in the reverse order, if we're starting with a gas over here, when it cools down it loses heat energy and it causes the particles to slow down. So what happens is they are able to form weak bonds again, and then we get what's known as a liquid. Then if it cools down even more, so when something cools, it loses heat energy. So if this liquid was to lose more and more heat energy, you get stronger bonds forming between the particles, and we get what is known as a solid. So that is just a little basic summary about the states of matter and their properties and why they are the way they are, and particle theory, and also changing state and why that occurs. So the most important points are knowing that the different states of matter, what they are, and that the particles are always constantly moving and interacting with each other. And because of this, that's why we get certain properties of substances. So what your job is to do now is going to your textbook and reading and summarising page 5 to 7, and then answering questions 1 to 6 on page 7.